In September of 1968, a Miami zoologist named Manson Valentine went into the water half a mile off the north end of Bimini in the Bahamas, roughly 50 miles east of the Florida coast, to look at something local divers and a low-flying pilot had already been talking about for weeks. What he found, under 15 to 20 feet of clear water on a shallow limestone bank, was a formation of stone blocks running north to south for close to half a mile, arranged in a shape that from above looked less like a beach and more like a road. The blocks were not scattered. They lay end to end and side by side in two parallel rows, some rectangular, some closer to flattened polygons, most of them several feet across and roughly 2 feet thick, fitted together along lines straight enough that early photographs of the site were captioned, without qualification, as the remains of a paved way. Valentine was not the first person in the water that year. Accounts from the time credit a handful of divers and at least one aerial sighting in the weeks before his visit, and the record on exactly who saw it first has never fully settled. What is not in dispute is what Valentine did next. He photographed the formation, measured sections of it, and brought the images to the press, where they ran within days under a name that has stuck for close to 60 years, the Bimini Road. North Bimini in 1968 was a small island with a small airstrip, a handful of dive charters, and a population that made its living mostly from bone fishing and rum-running history rather than archaeology. The bank the formation sits on is part of the Great Bahama Bank, a shallow carbonate platform that runs for hundreds of miles underwater, rarely more than a few fathoms deep. The same kind of ground that has produced flat-topped rock formations up and down the Bahamian chain for as long as boats have had glass-bottom buckets to look through them with. What made this stretch different in the fall of that year was not only what was under the water, it was who was already looking, and what they had already been told to expect. From the air, on a clear day with the sun high enough to kill the glare off the surface, the formation shows as two pale lines against the darker blue-green of the surrounding bank, running out from shallow water toward the drop-off, unmistakable against sand that everywhere else on that stretch of coast lies featureless and rippled by current. A charter pilot flying between Bimini and Miami in those years would have crossed it dozens of times with no name for what he saw. What changed in 1968 was not the rock, it was the sentence attached to it. If you're finding this story compelling, hit the like button and subscribe, and drop a comment telling me where in the world you're watching from. It means a great deal to know who is paying attention. The timing did the rest of the work. 30 years earlier, in 1938, a Kentucky-born psychic named Edgar Cayce, in one of several hundred trance readings he gave over 4 decades, had stated that a portion of the lost continent of Atlantis would begin to reappear near Bimini, and had given a rough window for it, 1968 or 1969. When Valentine's photographs reached newspapers in the fall of 1968, inside that same window, reporters did not need to manufacture a hook. The hook had been sitting in a stenographer's transcript for 3 decades, waiting for a diver to swim over the right stretch of seafloor. What divers actually found, and what still sits on that bank today, is worth describing in the terms a geologist would use before any terms borrowed from archaeology get attached to it. The blocks lie in water shallow enough to free dive, on a limestone platform that forms the shallow apron north of Bimini. They run in 2 roughly parallel lines for a distance of about half a mile, with a shorter perpendicular arm at the northern end that early observers read as a turn or a junction. Individual blocks range from roughly 3 to 6 feet across and stand about 1.5 to 2 feet thick, and the joints between them, especially where the rows curve, follow lines straight enough to photograph as masonry from a boat. Some blocks show a rounded, almost cushioned upper surface. Others sit tilted, as though settled or shifted, rather than laid flat and left. There is no mortar anywhere in the formation, no fill between the joints, nothing binding one block to the next beyond the weight of the stone itself. Divers who worked the site in its first years described swimming the full length of it in a single breath-hold pass along the surface, following the double row out until the water darkened and the bottom dropped away toward the edge of the bank, and more than one of them, in interviews given decades later, still used the word road without qualifying it, because that is what it had looked like from 6 feet above it, with the sun coming down clean through shallow water. Early accounts made much of the size and regularity of the blocks, and little of what a diver finds if a knife or a probe goes under the edge of one. Beneath nearly every block that has been examined, divers and later researchers found the same limestone continuing downward, unbroken, as a single sheet running under the entire row. The blocks were not laid on the seafloor. Wherever anyone has looked closely, they are still attached to it, cracked apart along lines but rooted in the platform they sit on, the way a sidewalk cracks into slabs without the slabs ever leaving the ground beneath them. A formation that size, sitting in water that shallow, off an island that small, did not stay unexamined for long. It took a decade for the right instrument to reach it. The formal answer to what the Bimini Road actually is came in 1978, and it came from a scientist with no stake in either side of the argument. Eugene Shinn, a marine geologist with the United States Geological Survey, who had spent years studying the growth of reefs and shallow carbonate banks in the Florida Keys, went to Bimini specifically to test the formation rather than to argue about it. Shinn's method was not photography or measurement from above. He drilled. Using a hand-operated coring rig, he and his team took a series of cylindrical samples straight down through several of the blocks and into the rock beneath them, the same technique used routinely to date and classify limestone formations anywhere on Earth. The work was not glamorous. It meant anchoring a rig over a few feet of open water, driving a hollow steel barrel down through rock that had already stood as a tourist attraction for a decade, and pulling up a core no wider than a fist, over and over, block after block, until the sample set was large enough to mean something statistically rather than anecdotally. The cores came up as a single, continuous column of rock in every hole, with no seam, no fracture plane, and no join between what lay above the visible crack in the seafloor and what lay below it. In geological terms, that is close to conclusive. A cut and fitted block, laid by hand on a prepared surface, leaves a boundary a coring bit will hit and register, a change in rock texture or density at the point where two separately formed pieces meet. Shinn's cores showed nothing of the kind. What they showed was beachrock, sand and shell fragments, cemented together by calcium carbonate, precipitating out of seawater near the tide line, a process that happens along tropical and subtropical coastlines worldwide, and produces exactly the kind of flat-topped, rectangular jointing visible at Bimini, as the cemented layer dries, contracts and cracks along regular lines the way a dried mudflat cracks into polygons, only harder and permanent. Radiocarbon dates run on shell material from the cores put the rock's formation at somewhere between 2,000 and 4,000 years old, consistent with a beach that once stood at close to today's sea level and has since been submerged by the slow, ordinary rise of ocean water that has been underway across the whole Caribbean basin since the end of the last glacial period. Shinn cross-checked the Bimini cores against beach rock formations he had already studied and dated on Andros and along the Florida Keys, where the same cracking pattern shows up above water, on dry land, in places nobody has ever proposed a lost civilization to explain. The jointing at those dry sites splits into the same roughly rectangular pattern, at the same scale, for the same reason. A hardening slab under tension breaks the way brittle material breaks, along lines that look designed because straight lines are simply the most efficient way for a crack to relieve stress across a flat surface. If this investigation has your attention, subscribe and turn on notifications. There is more to uncover. Your support makes it possible to bring these buried histories to the surface. Shinn published his findings, presented them to the Geological Society of America, and by most measures considered the question closed. It did not stay closed in public. A formation that geology explains in a paragraph, tropical beach rock, calcium carbonate, tidal cracking, does not compete well against a formation tied to a 1938 prophecy and a name like the Bimini Road. For every paper reaffirming the natural origin, dive tour brochures and later researchers, Among them a geologist named William Donato, who continued surveying the site into the 1990s, kept arguing for deliberate construction, pointing to the block sizes, the double-row arrangement, and a small number of adjoining rounded and rectangular stones nearby that resemble worked column drums. Mainstream geology has not moved. The published record on Bimini, from Shinn's coring onward, describes beachrock. What remains genuinely unsettled is not the coring data itself, which nobody has seriously contested, but a handful of anomalous nearby stones that Shinn's team did not core and that later investigators say do not fit the beachrock explanation as cleanly as the main formation does. A short distance from the main double row, divers have photographed several rounded stones, each roughly 2 feet across, sitting apart from the flat blocks and closer in shape to a worked drum than to any beachrock fracture pattern on record, and Donato's later surveys treated those few stones, not the half-mile of straight rows, as the strongest remaining piece of unfinished business. No coring has ever been published on them. Until it is, that small cluster is the one part of the Bimini Bank where the record genuinely stops, rather than simply disagreeing with itself. Bimini is not the only stretch of shallow water where a diver has surfaced, holding a photograph of straight lines, and had to wait years for a geologist to settle what it meant. In 1986, a dive boat operator named Kihachiro Aratake was scouting new sites off the coast of Yonaguni, the westernmost inhabited island of Japan, looking for places to take hammerhead shark tours during the winter migration season, when he came across a submerged sandstone formation roughly 250 feet long and 80 feet high, rising out of open water like a stepped building with no explanation for why it should be there. He surfaced, told other operators, and within a season, local divers were swimming a formation cut with what look, from certain angles, like stepped terraces, a wide flat platform, and something close to a right-angled corner. A University of the Ryukyus geologist, Masaaki Kimura, spent decades afterward arguing the formation was substantially shaped by human hands, pointing to what he read as carved steps and drainage channels. Other geologists working the same rock pointed instead to Yonaguni's sandstone bedding planes, which fracture naturally along near-perfectly straight lines under stress, the same mechanical property that gives the island's dry land coastline its famous stair-step cliffs, visible above water where nobody disputes that no one built them. Robert Schoch, a geologist from Boston University, who dove the site directly to test Kimura's claims, reported the same conclusion from the opposite side of the debate, that the terraces followed bedding and joint planes typical of the local sandstone, and that similar stepped, angular formations exist on dry Yonaguni terrain, a short walk from any diver's hotel, unclaimed by any explanation involving ancient construction because no one had to swim to notice them. The Yonaguni monument remains argued and undecided in a way Bimini's coring data mostly closed, but the shape of the disagreement is the same one. A real, physically striking formation, a geological explanation grounded in a rock's own fracture behavior, and a public appetite for the other answer that has outlasted the data either way. The clearer counterexample runs in the opposite direction, and it is worth holding up against the other two, because it shows what the positive case actually looks like when the evidence supports it. In 1967, a British oceanographer named Nicholas Fleming surveyed a shallow bay off Pavlopetri on the southern coast of Laconia in Greece and mapped what turned out to be an entire submerged Bronze Age town. Building foundations, courtyards, streets and burial sites laid out across several acres of seafloor, later dated to at least 3,500 years old, and confirmed, over decades of subsequent excavation, as the oldest known submerged town anywhere in the world. Pavlopetri is not a boundary case. Divers can swim the actual street grid. The methods that confirmed it, stratigraphic excavation, pottery typology, radiocarbon dating of organic material recovered in context, are the same methods archaeology uses on dry land, applied underwater by trained excavators across repeated seasons, and they produced an answer nobody has needed to keep arguing about since. Later survey seasons, carried out with acoustic mapping and photogrammetry, rather than the tape measures and hand sketches Fleming worked with in the 1960s, extended the known town to roughly 9,000 years of continuous coastal habitation in the wider area before the final Bronze Age settlement was drowned by earthquake subsidence and rising water sometime around 1100 years before the Common Era. Every building line at Pavlopetri sits inside a dated stratigraphic sequence, checked against pottery styles that are independently dated on land sites across the Peloponnese, which is the difference between a photograph that looks like a road and a town that has been excavated, layer by layer, the way any archaeologist would insist on excavating one on shore. What connects the three sites is not a hidden civilization. It is a fact about how humans read stone. A straight line under clear water photographs the same way whether nature made it through thousands of years of tidal cracking, or a mason cut it 3,000 years ago, and the eye that first sees it underwater, excited and out of breath, is not equipped to tell the difference. Only the slower instruments are a coring bit, a radiocarbon lab, an excavation grid laid out over multiple seasons. At Pavlopetri, those instruments confirmed the human hand. At Bimini, they found the tide. At Yonaguni, the argument is still open because the instruments have not yet closed it the way they closed the other two. The Bimini Road itself has not gone anywhere and has not been hidden by anyone. It sits where it has always sat, in 15 to 20 feet of clear water half a mile off North Bimini, a site any licensed dive operator on the island will take a paying customer to see within an hour of the dock. Snorkelers swim over it by the boatload every winter season, and charter listings still advertise the trip by the name the newspapers gave it in 1968, because a road sells more seats on a boat than a beachrock formation does, whatever the coring data says about which word is accurate. The blocks are still cracked into their rough rectangles, still rooted in the limestone beneath them, the way Shinn's cores showed them to be rooted in 1978, still visible from a boat on a calm day as two pale lines running out toward deeper water. Nothing about the site has been suppressed, restricted, or removed. What has happened instead, over close to 60 years, is a quieter kind of persistence, a scientific answer, published and largely uncontested within its own field, sitting alongside a popular story that a psychic's forecast and a diver's photograph got there first and never fully let go. Valentine died in 1994, still describing what he had found as evidence of an advanced, vanished culture, and he was not alone in that conviction. He had spent a career as a naturalist cataloguing the ordinary, unglamorous facts of the natural world, and the one find the public remembers him for is the single case where he read the record the way the story wanted it read, rather than the way the coring bit later confirmed it. Shinn, for his part, kept publishing on Florida and Bahamian carbonate geology for another 3 decades. Bimini, a small, settled chapter in a much longer career spent studying how limestone platforms grow, crack, and drown along the whole rim of the Caribbean. Both men worked from the same rock, walked the same half-mile of shallow water, and stood over the same pale lines running out toward deeper blue. Only one of them drilled into it, and only one of them found out what it was made of before he decided what it meant. Neither man lived to see the argument settled in the public mind, because it has not been. The Geological Society of America accepted Shinn's Beachrock explanation without much internal dispute, and geology textbooks that mention Bimini at all now list it, when they list it, as a well-documented example of how flat-topped tidal jointing can be mistaken for cut masonry by an untrained eye moving fast through clear water. Outside that literature, in dive shop brochures and late-night television, and the comment sections under any video that shows the formation from above, the road has never stopped being a road. The blocks do not care what they are called. They have gone on sitting exactly where the tide cracked them, exactly as far down as Shinn's cores found them rooted, for as long as anyone has been arguing about them, and they will keep sitting there, unmoved by either argument, for as long as the Bahama bank itself holds its shape beneath the water. Thank you for staying with this until the end. If what you heard here stayed with you, the other films on your screen continue the investigation. Subscribe if you haven't, and I will see you in the next one.